Welcome to this session on network security and forensics. Until now, we saw how packets can be captured and analyzed using the different tools like Wireshark, T-Shark, etc. Okay, we saw that first is the data acquisition, and once the evidence is acquired, you can actually use different kinds of tools, and you can also develop your own tools to identify what is the issue and how some activity had taken place. We were mostly concentrating on wired networks. So, we would briefly look at wireless network forensics and what are the minor differences, because there you act on wires, whereas here you act on some radio frequency networks. Therefore, the difference is that you need to understand about the protocols that are various protocols that are used. So, we will give you a very brief overview of various protocols, wireless protocols that are used, and why we should know these protocols is that it will be helpful for doing the right type of forensic analysis. So, what we will do is we will look at the different types of 802.11 protocols, okay, I mean different frequencies at which it operates. So, other thing that you should know is that, see, previously for acquiring the Ethernet tap, we just you could have a tap and you can get the data, but here you have to connect another device from your machine and then try to scan what is there and then get the data, whatever data is going through in the wireless networks. Okay. So, there are many common wireless devices like AM, FM radios, cordless phones, cell phones, Bluetooth, etc. Okay. And there are also the Zigbee devices, okay, which are used for high voltage air conditioning and thermostat, lighting, electric controls, I mean short distance communication. And then you have the Wi-Fi, okay, 802.11 and then WiMAX, okay, and Wi-Fi is very prevalent, and this is one of the security loopholes is provided by Wi-Fi. There are many cases that involve wireless networks. Okay. One is it could be a stolen laptop, okay, where you could try to actually get back the laptop that is connected to a wireless network. Okay. So, you could actually recover the laptop, okay, when it gets attached to a wireless networks. Okay. You could also look at some wireless rogue access points. I mean, it is known as something known as war driving. So, what usually these hackers do is that they actually install some wireless scanning software or device and then go on scanning, finding out vulnerable wireless networks, okay, usually 802.11. See, many of us actually leave the default password for routers. Okay, and one of the things, okay, for security is, please ensure that if you are a network administrator, never leave any default installation. I think many of us feel very convenient by pressing the default button and then installing software, and this can lead to a lot of vulnerabilities. Okay. For example, a simple example is that everyone expects SSH to work on port 443. I mean, so suppose I do not use the default 443, but I use some other port, okay, say some other unknown port, okay, then at least you provide a wall for the hacker, okay, to make him do some more operations rather than just barging into port 443. I mean, it is like providing 2 or 3 locks to in your house. I mean, whether it is going to ensure that a thief never enters, no, but at least it can delay the entrance of the thief. So, similarly, okay, using default values for installation can lead to lot of security holes. So, please ensure that if you are a network administrator, do not go for default installation, look at every installation case and see how security can be incorporated, while or what are the ways by which security can be enhanced by during installation by not providing default values. Okay. So, for example, many of the password attacks like I mean some 1 2 3 4 5 6 7 8, which is one of the most used passwords, etc. Okay, because that could be the default and that is easy. Similarly, admin, login name admin, I mean password is admin. I think many of the wireless routers will break if you use these kind of passwords. Okay. So, ensure that you do not go for this kind of default. Okay. So, what are the other things that we can do? We can actually, so especially this kind of wireless rogue wireless access points that have been installed by insiders. Okay. So, many times what people will do is that they call it as a evil twin or something. Okay. So, what they do is I will install a wireless device with the same key of an official router. So, people will think that I am the official network and they will try to connect to me, thereby I can extract data from them. Okay. You could also, there are cases that involve malicious or inappropriate activity that occurred via wireless network, because I am see bring your own device kind of stuff. Okay. So, I bring my device which has lot of virus and then I connect it to the wireless network, I spread it to everyone. Okay. And wireless networks are mainly open. So, unless Ethernet, where you at least you have to go to a place and then you can't roam around. Here I can actually log on to whatever place I want and then I can spread my virus happily, okay, and feel happy about it also sometimes. Okay. So, other things that you can involve, other cases that were seen were like denial of service, okay, encryption cracking. So, for example, I mean if I connect to my wireless network, what is the secret key? Okay, I can use some scanner device and then crack some well known passwords and things like that. So, wired I mean in wired networks it is slightly difficult because you have to physically go and connect the device, whereas in wireless, yes, I can just have my wireless on and then do all these activities. Okay. So, wireless has a bunch of security loopholes. Okay. So, before we go into wireless, we need to understand some of the IEEE layer 2 protocols. Okay. So, 802.3 is the Ethernet protocol. So, if you look at Wireshark, you would have talked about Ethernet 2, okay. 802.1q is the trunking, and then 802.1x usually is the LAN based authentication, and 802.11 is the Wi-Fi, okay, and it operates on 2.4, 3.75, usually it is 2.4 and 5 or usually used. 2.4 is the one which is used, okay. And if you look at this, the RF has different characteristics than copper, therefore, the protocols that are used are different. For example, I mean one of the places is that even TCP, okay, in wireless there could be much more higher amount of drops because of weak signal, etc., whereas in Ethernet you generally do not come across those kind of problems, I mean unless you configure it badly, I mean incorrectly. Okay. So, but in wireless you can have signal loss. You could have a lot of retransmissions, I mean. So, because of all these things, okay, what usually we do is the protocol for wireless is different from protocol that is used for Ethernet. Okay. So, what happens is that the wireless protocol encapsulates the Ethernet and then it transmits it in the wired networks, in the wireless networks. Okay. Usually we will be concentrating more on 802.11. and 802.11 has three different frame types. Okay. The first is the management frame, the control frame and the data frame. So, we should be aware of all the three frames, because when you are doing a forensic investigation or an audit, okay, all these frames will matter. Okay. Management frames actually govern communication between two stations, okay, except for the flow control, and then control frames support flow control. Okay, and then the data frames actually encapsulate the layer T data, and I mean the data frame is the one which actually moves the data between stations on a wireless network. Okay. So, management frames are given as type 0, and these are the ones who coordinate communication. Okay. The forensic benefit of management frames is that it is not encrypted, okay, it uses MAC addresses, so it uses BSSID, okay, you can get the service set identifiers, okay, and these are actually the point of attacks, okay, like evil twin, okay, attacks. Okay. Evil twin is using the same name for the wireless network connection as what is already existing. Then you can crack, okay, you crack the web protocol, okay, the secret. Okay. This frame looks something like this, okay. So, we will look at you will have to look at the flags. I mean you do not have to remember all these things, but you need to understand what these flags mean. Okay. So, so for example, P is equal to 0 means the power management flag, and the idea is that okay, usually your Wireshark will interpret it for you. So, you need not remember all these things, but at least you should know what is the value of each one of the field. Okay, so here are some management frame subtypes. Okay, this is association request with a wireless network, and then you get a response. So, all these code, I mean you need not remember, but at least if you are using Wireshark, it will tell you whether it is association request or association response, and if you are able to successfully connect, it returns a successful connection. And then the probe request is to find out what are all the wireless networks. I mean if you open a wireless network, it tells you these are all the wireless networks that are available. So, and then you can associate with a particular wireless network, and then you can disassociate. Sometimes these kind of hopping happens quite automatically. For example, you could even hop from a 3G or a 4G network to a wireless network, or wireless network to 4G network, etc. So, all the, even between wireless networks, from one wireless network to another wireless network. Okay. Then these control frames are type 1 frames. So, essentially it is similar to sending and receiving data in more or less a serial link. Okay. For example, it has a request to send and clear to send. Those who have worked with UART will be very familiar with all these things. Okay. Anyway, I mean this is a medium, and you have to transfer data from one machine to another machine. Therefore, you have to have some sort of an acknowledgement to do flow control, otherwise you will be barging in all the data. And one of the things we need to have for flow control is because there is limited bandwidth, okay, in wireless networks. So, because of that, you or not everyone can go and congest the networks, and if the network congestion happens, there is drops and all these problems occur. I hope these were all covered in your previous IS courses. Okay, then type 2 frame is the actual data frame. Okay. It includes encapsulated higher level protocols. Okay. So, so all the 3 frames, okay, type 0, type 1 and type 2 is of importance for a network forensic specialist. Okay. So, while doing frame analysis, you need to be careful about the endianness. Okay. This was actually covered in your previous courses as network to host and host to network. Okay. So, it essentially big endian means that the most significant byte represented are stored or transmitted first, whereas little endian is least significant byte represented, stored or transmitted first. Okay. So, if you look at this, okay, so sometimes what happens is that you could also have a mixed endian format. Okay. So, here is an example. Okay. So, if you look at the first 2 bytes of IEEE 802.11 frame header, you see 0 0 1 0 0 0 0 0. This is the way this is represented, but the way it gets transmitted is the other way around. So, if you look at this, the subtype gets transmitted first, and then this type gets transmitted next, and the version gets transmitted third. So, but you do not have to worry about it, because here is in Wireshark you can just will correctly interpret these things. Okay. So, one of the things is, yes, you should be aware of this, and if you look at the Wireshark, so it gives you all the information. So, it talks about the frame control, okay, and then it talks about the version, and it says that it is a data frame. Then it looks at the flag, okay, and so if you look at this, okay, so if you use Wireshark, you will be able to interpret all these frames correctly. So, what we will do in the next module is that we will look at wired equivalent privacy, okay, and why is this used, and why is there a security vulnerability in wired equivalent privacy, and we will see how this is broken. Okay, you can actually use a brute force attack to break this, and then why is it still used, etc. All these things we will see in the next module. Thank you.